Motion in one direction. This is what we'll be learning now. And as we start, let us understand some terms that is related to motion. Okay, some of the terms that is related to motion. In the start, let us learn about scalar and vector quantities. I'm sure you have already heard about this and you have learned about this before. Let us define the scalar and vector quantity once again. It would just be a revision for you. Scalar and vector quantity. Let's see what is scalar quantity. Now, the scalar is the measurement of a medium that is strictly in magnitude, right? I hope you can remember this, that the scalar quantity describes only the magnitude, whereas vector, this is a measurement that refers to both the magnitude and direction. In short, right? So vector is a measurement that refers to both the magnitude of the medium as well as the direction of the movement of the medium has taken, right? The direction at which the medium has taken. So that is vector. So I hope you have understood the difference between scalar and vector. In very simple, scalar describes only the magnitude, vector describes both the magnitude and the direction. Let's see some examples. Let's see the example for scalar quantity. Let us say that the mass of a body is 10 kilogram. Well, like you can see that there is a weight plate, a weighing plate. Now you have to remember one more thing, that we need two parameters to express a scalar quantity. The first is the unit in which the quantity is measured, and in this case the unit is kilogram. Okay, two parameters to express a scalar quantity. The first is the unit and the second is the numerical value of the quantity. The numerical value in this case is 10. So these are the two parameters to express a scalar quantity. The first is the unit in which the quantity is measured and the second is the numerical value. Let's talk about vector quantity. Okay, let's see an example for a vector quantity. Suppose if I say, or suppose if we say that move or displace an object from a point by 10 meters. The first question that would come in your mind is, in which direction, right? I've just said that move or displace an object from a point by 10 meters. So the question would say which side. By saying that displacement is 10 meter, its meaning is not complete, right? Just by saying that the displacement is 10 meter, its meaning is incomplete. What makes its meaning complete? If we say that displace the object by 10 meter towards west or maybe any direction. So suppose if I tell you that move this weighing plate from this point 10 meters westward or eastward. Now you get it, right? It has a complete meaning. Let's see another example. You can see a bicycle. Let me say that I want you to move this bicycle 50 meter eastward. Okay, you have to move this bicycle 50 meters east. The weight of the bicycle is 8 kilogram. You have to move this 8 kilogram bicycle 50 meters east. Right? I hope you have understood this. Now, in a vector quantity, we need three parameters to express a vector quantity. Three parameters. Unlike in scalar quantity, we need two parameters to express. The first parameter is unit. Right? In this case, the unit can be kilogram or meter. The second parameter to express a vector quantity is direction. And which side you have to move the cycle? Eastward. And the third parameter is the numerical value of the quantity. The numerical value of the quantity here is you have to move 8 kilogram. Okay, let's see more about scalar quantities. Now these scalar quantities are measurements that strictly refer to the magnitude of the medium, right? You know about this. So scalar quantities are the measurements that strictly refer to the magnitude of a medium. Let us understand what is this magnitude. This magnitude refers to the quantity or distance, okay, like in a relation to the movement. We can connect this magnitude, or we can correlate magnitude with the size and speed of the object while traveling. Okay, so the size of the object or the amount is its magnitude. Like the example that we saw, weighing plate 10 kilogram, right? So 10 kilogram is the magnitude. Let's see an example. Like in the case of speed, a train is traveling faster than a car. Okay, remember that the train is traveling faster than a car. And in this case, the magnitude of the speed of the train is more than that of car. Okay, I hope you're understanding this. The magnitude of the speed of the train is more than that of a car. So what's the magnitude? The size of the object or the amount is its magnitude. Okay, now there are absolutely no directional components in a scalar quantity, only magnitude, no directional components. Right? I'm sure that you have understood this. Let's talk about time. Okay, based on scalar quantity. Now, scalar quantities often refer to time. Let it be the measurement of years, months, weeks, days, hours, minutes, seconds, and even milliseconds. The next we'll be seeing is volume. Okay, scalar quantity can refer to the volume of the medium, as in how much of the medium is present. How much of the medium is present? Air, water, right? Everything from tons to ounces to grams, milliliters, and micrograms are all scalar quantities. Till when? As long as they are applied to the medium being measured. As long as they are applied to the medium being measured, and not the movement of the medium, not the direction. Let's talk about speed and temperature based on scalar quantity. Now these are two more commonly used scalar quantities in physical calculations: speed and temperature. When will these two be considered as scalar quantity? Speed and temperature will be considered a scalar quantity as long as they are not associated with directional movement. They remain scalar quantities. I hope you're understanding this. For example, the measurement of speed in miles or kilometer per hour, or the measurement of the temperature of the medium, both remain scalar quantities. Till when? As long as they are not associated with direction of the medium's travel. As long as they are not associated with the direction of the medium's travel, speed and temperature also will be considered as scalar quantities. I hope you have understood this. Now let's see some more things about vector quantities. Okay, now you know that vector is concerned with magnitude, both magnitude and direction. So vector quantities, however, they refer to both the direction of the medium's movement, right, and as well as the measurement of the scalar quantity. So we have both. Measurement of the scalar quantity is nothing but the magnitude. Okay, now let's understand about temperature. When will that be called as, when will it be a vector quantity? Increase, decrease in temperature. The measurement of the medium's temperature is a scalar quantity. The measurement of the increase or decrease in the medium's temperature is a vector quantity. Till the time temperature has not changed, there is no movement, it's a scalar quantity. Once it increases or decreases, a vector quantity. Let's talk about velocity. The measurement of the rate at which an object changes position is a vector quantity. The measurement of the rate at which an object changes position is a vector quantity. We will see an example here. Let's suppose if a person quickly moves one step forward and then one step backward. Okay, quickly move one step forward and one step backwards. There would certainly be a lot of activity, right? But there would be zero velocity. Right? I hope you're understanding this. There will be zero velocity in this case. Now, in order to measure the vector quantity of the medium, okay, if we have to measure the vector quantity of the medium, there must be what? A directional measurement, right? There should be a directional measurement applied to the scalar quantity. A directional measurement applied to the scalar quantity. Let's see an example. Regardless of how fast an object is moving or an object is going, the direction of the movement must be described in the velocity vector. Like the object is moving rightwards or the object is moving forward, right? Till the time we do not express this, it cannot be called as a vector. Let's understand some more about the scalar quantity. We can add, subtract, divide and multiply the magnitudes of scalar quantity just by a simple calculation. Like for example, we have three sides of a triangle. Let's say one is 2 meter, second is 4 meter and the third is 6 meter. We have to calculate the perimeter, and I think you know how to calculate the perimeter when we add all these three sides. How do we do? A simple calculation, right? 2 meter plus 4 meter plus 6 meter is 12 meter. But remember something here. We add only the magnitudes, right? 2, 4, 6. But the unit remains the same. We do not add the units. We only add the magnitudes. That's why we got 12. So a scalar quantity is symbolically written by its English letter. Like for example, mass is represented by letter M as lowercase, time is represented by the lowercase t, and speed is represented by lowercase v, the English letter. Let's see about vector quantities. Now, vector quantities, they too have magnitude, but with direction. Some of the vector quantities are like displacement, velocity, acceleration, force, and some more. We call the magnitude of a vector as its absolute value. Okay, remember this. We call the magnitude of a vector as its absolute value. Now, when we have a negative sign with a vector quantity, it implies the reverse direction. Remember this, when we have a negative sign, it implies the opposite or the reverse direction. Let me explain you with an example. Let's say the forces plus F with an arrow sign on top and a negative F with an arrow sign on top. These are what? These are two opposite directions, right? And a vector quantity is generally written by its English letter, but remember there is one thing additional here. It bears an arrow on it, just like you see in the example. It can be an arrow or it is written by the bold English letter. Let me show you some examples here. Velocity. It can be written as V with an arrow sign on top or V in bold letter, but this should be in small letter, lower case. Acceleration, it is written as a lowercase a with an arrow on it or a bold letter A. Force, we saw in the example, it is written as capital F with an arrow sign on top or capital bold F. Now there are some more examples of scalar quantities. Scalar quantities are also known as scalars. You can just go through all of these. Okay, these examples. And there are examples of vector quantities. Now vector quantities also are known as vectors. You can go through these examples. You'll be learning about this in your higher classes as you go. Okay, I hope you have understood this. We're learning motion in one direction. We'll be learning more about it in the next note. Keep revising and keep learning it.